variation of resistance with temperature. As the temperature of the surroundings increases, the resistance of the material changes. The reason for this change is not because of the variations in the dimensions of the material but rather the change in the resistivity of the material. When there is a rise in the temperature, the heat will cause an atomic vibration, and these vibrations will cause a collision between the free electrons and the electrons in the inner layers of the atom. These collisions will use the energy of free electrons. If more collisions take place, more energy of free electron is used and increases the resistance to flow of current. This is the case in conductors. In case of insulators, the resistance decreases with increase in temperature. The reason is the availability of number of free electrons which are released from its captive stage. In mathematical terms, a fractional change in resistance is directly proportional to the change in the temperature. In mathematical terms, a fractional change in resistance is directly proportional to the change in the temperature. R/R0 proportionality T. Where R is the small change in resistance. R equals R, R0. R is resistance at temperature T. R0 is resistance at temperature T0. T is change in temperature. T equals T, T0. If we denote the proportionality constant in the above equation as alpha, alpha, then R/R0 equals alpha T, where alpha is the temperature coefficient of the resistance. The temperature coefficient of resistance is used to describe the relative change in resistance in association with change in temperature. If the change in temperature is small, then the above equation can be written as R equals R01 plus alpha, T0. If the resistance increases with increase in temperature, then the material is said to be having a positive temperature coefficient. These materials are conductors. If the resistance decreases with increase in temperature, then the material is said to be having a negative temperature coefficient. These materials are insulators. Resistance of a conductor can be defined as the conductor's opposition to the flow of current through it. Resistance is a property of an object like conductor. Resistivity is a property of a material from which the object is made. Resistance value of a given resistor can be read from the resistor color code given on it.